Last section here in the work chapter is power. Because doing work is just a force through a distance. So your car applies some force, right, to the road through the tires, and the road applies an equal and opposite force back on the car. And after some distance, your car is moving. Let's say you're at a metering light waiting to get onto the freeway. So you're starting out at rest, and then you're moving at some speed. V final, right after you've gone down the ramp to get onto the freeway. But there's a difference, right? So your car took a certain distance, right? The work done, I should say, force times distance, is the same. Now let me rephrase that. The work done equals the change in kinetic energy of the car, right? So your car went from whatever, 0 to 60 miles an hour. It had a certain change in kinetic energy. Maybe the car next to you at the metering light also was the same mass, and it went from 0 to 60 miles an hour, had the same change in kinetic energy, the same work done on that car as your car, but that car did it much faster. It came up to 60 miles an hour over here somewhere, while you needed a much longer distance. So where does that come in, right? That's important sometimes. How fast you can do the work is sometimes important. Maybe you have a little electric motor that can lift something up, but it takes a long time to lift it up. And you have another electric motor that can lift the same weight, the same distance, do the same work, but it can do it much faster. Right? That might be important to you to know that. So that's where power comes in. Power is work divided by time. A joule per second. The units are joules per second. We get tired of writing joules per second. So we call that a watt. Capital W. Because we didn't have enough W's already, did we? Weight, work, watts, lots of W's. It's okay, next quarter you're going to have a lot of V's to deal with. Work over time, watts, joules per second. So this is sometimes important to us, right? That other car that could do the same amount of work in a shorter distance. Why could it do the same amount of work in a shorter distance? It could apply a bigger force to the road, right? It had a bigger, more powerful engine that could apply a force, bigger force. So if you can do the same amount of work in a smaller distance, you have to have a bigger force. Work is force times distance. The force has to be bigger if the distance is smaller to do the same amount of work. So work over time, power. Units, for us, watts, right? That's the SI unit. That's what we use all the time. But you often see other units, you often see horsepower, right? Like our cars are typically rated in horsepower. So there's a conversion factor in the book to go from horsepower to watts or vice versa. But the unit we use is the watt.